I'm very glad to be here, and I'm very proud because this is my third time in Portugal. Thank you for organizers. And right now, I offer you to talk or to think about complexity. Complexity in our code. And also, we can think or discuss how we can spread complexity. And this my talk is the third part of series of my talk about distributed complexity and simply about complexity in code. Before I start, I want to say thank you for my family who supported me on every conference which I participate. Thank you for my wife, Elena. Thank you for my animals, Marcel and Kisa. And special thanks to my children, Mark and Maya, because they are illustrators for this presentation. Thank you, Mark and Maya. If I say wrong, Mark and Maya. Marcel and Kisa is animals. Okay, and let's go. Who I am? I am Maxim Danilov. I work more than 26 years in commercial software development, and 9 years I work deeply with Python and Django, and more than 6 years I work with different reactive frameworks, front-end frameworks. Also, I'm already 7 times won the title Super Mentor in Engineering, and I offer author support for newbies in Python or in programming on the mentoring platform for free. Many years. Okay, and let's go. All successful startups are happy in their own way, and all mature projects are unhappy in the same way. I have seen many matured projects written on Python or on other programming languages, and I have collected some similar signs about complexity in project. Let's imagine. In 2000, startup starts in 2013. In 2015, it was big Django project, a little bit with REST API implementation. But 2 years later, it was not enough, and some elements in this project was added, and these elements used Flask somehow. And after that, in 2018, it was all run with AWS Lambda, and later in 2019, Fast API was added in this project, but CTO was not happy with all solution, and every year he tell on the monthly meetings, boys, we should refactor this whole mess. And after that, it came cloud computing from Google, and after that appears Lightstar. Previously, it was Starlight. After that, it was renamed. Lightstar appears in project, and probably you know Django Ninja also was included in this project. And later, I came in this startup last year, but this is not more a startup. This is already how many years? 10 years. And with my help on this project, start works with micro Django paradigm. This is I did many talks in this year about this paradigm. Micro Django means some APIs or endpoints run it with asynchronous micro or nano containers built on Django. Okay, probably you already can understand this is a huge project we can calculate as around 300,000 lines of code with different frameworks, built with different frameworks from different programmers. And this is really one mess to work with it. And refactoring to this solution, to this implementation is not a solution. At first, refactoring takes time. If I create this project around 10 years, probably 6 years takes refactoring for that. Refactoring stops our growth, but we cannot stop growing of project because we can lose the customers who pay their money. And refactoring increase costs and not increase incomes. And in other words, I like this sentence. Refactoring converts old bugs and wrong decision into other bugs and other wrong decision. That's why I hear many times from different developers, we should refactor this all, and I only can third. You don't understand what are you speaking. Microservices. Microservices, this is interesting paradigm, and probably we can transform our project on the microservices. But in the same time, this is also refactoring. And we got the same effect. We stop growing of our project. We block teams to refactor monolith in microservices. And what we can do? And in this case, I can offer you how I offer for CTO of this project the idea about modular monolith. Modular monolith was perfectly described with Camille Gritzberg. It was around 5 or 6 articles about it. You can find it in the internet. And accordingly to this idea, I create some small project which calls dependency extractor. And right now I want to tell you how I work with huge and complex projects with this paradigm and this library. At first, generally, we have monorepo monolith only with one entry point. What I mean entry point? It's not, usually this is a web entry point, but this can be command for script. Some function which solves somehow business task. This is entry point for business. And we have solved the first business goal with this entry point. After that, we have other business goals, and we create the new entry point. And you can see the new entry point reuse some code. Not always, but can reuse. And after that, the project grows, and we have more and more entry points or more and more solution for business tasks, and also some reusable code appears. But somehow this monolith transforms in a messy project, and Gritzberg offers us to think about we can split monorepo on different modules. The first entry point, the second entry point, and they simply we can store these entry points in different folders. Of course, don't repeat yourself a rule completely broken. I understand it. I accept it. But this is not bad. Okay, we split our code on different entry points. And I create the script accordingly. This script used IST model from Python. You can download it, you can use it as is. And what we can do with this script? Simply, I provide the name of file in my big project, and after that, in this file, the script finds different imports and copy in different folder. Not only this file, also this script copy imported modules, and it made it recursively. IST goes through, it's simply a small script. It goes through the text of file, find import node from IST, and every time marks, okay, if this import happens, we should copy also imported file. And you can see, I collect the imports from the first file. After that, accordingly the order of imports, I copy the other files. In every copied files, I again collect imports, and somehow I collect all files which I need in one folder, which provide for me working entry point, only one entry point. And this is really interesting because this entry point works. All internal dependencies collected. We can easily pack this entry point in one independent container or more entry points. And interesting is, I don't do any refactoring. This is only copy file to other folder. My idea not works if code written without declaration some external or internal dependencies somehow. Sometimes this idea not works. I use it with PyTorch. Sometimes it not works because I still not able to copy dependencies with C libraries. Probably, I hope I extend this script for that. And sometimes dependencies named others, like folders, and in this case, yeah, it's also not works. And some issues also discovered in Python. For example, relative imports and symlinks not works perfect in Python or with IST module. Also, sometimes developers forget to catch errors on collect environments in modules. And sometimes if you write doc strings with HTML tags, in this case, IST module is also false. And sometimes importly breaks our game. But which advantage I have with this script or this idea? At first, I spread technical or cognitive complexity through different folders. And after that, I can split teams for supporting only small parts of code. You can see on the left side we have messy monolith. On the right side we have blocks of code for every team member. Advantages also, and this is important, I don't do any refactoring with code. Also, we got it a little bit later. We see it reduce container image and reduce package loading time to the external storage. And we can run extract procedure exactly before creating the image for container. And of course, it's clear, understandable. If we got some errors on production, we can stop only selected container and refactor select code in selected container if it important. But we should not stop the whole container with our monolith. And result, simply result on the chosen project. We have source folder with 2,700 files as 700 folders and 21 application in Django application paradigm. As a result, only for one entry point, we have coupled around 750 files. In my opinion, this is the bad engineering solution because this is too high coupling. And probably you can remember we have a rule, low coupling, high cohesion. And also in this script, I prepare foundation for future changes in project. I create report about imports, I create report about imported classes, and I create also information, I collect also information about how many classes imported from line to line, from on one import line. And what we have in this report, for example, report about classes, we can see in the class enum imported for work in one entry point container, it's imported 112 times. And other helper classes also imported around 100 times. Probably. This is only the signs about these elements can be packed in external model and can be stored also in repository, and it can be also imported if it important like a external dependency. Probably. The next report tell me about imports. For example, in one file we have 73 lines of import. This is, my opinion, this is a problem. Of course, I understand what happens there. This is like a Java developer start to write the Python code, and they create service factory. And in this case, this is a GOT object, and they collect all objects from whole project. In this case, this is a wrong decision, and this report simply to show me the places their complexity is concentrated. Probably these files can be somehow refactored or rethinked. This solution can be re-implemented. But simply try to imagine. Every normal developer can keep in head around from 7 bis 10 elements. And somebody imported more than 73 classes. I'm not genie to work with all these classes, to keep all this in my head. And probably nobody can do it. Probably, I'm not sure. And let's go deeper. I start to investigate this project, and what I find a little bit later. I find what some imports we have only to define type hints. It means they don't do anything anything else, only they imported for type hinting. Okay, and I thought, what happens if I remove type hints and if I delete unused imports? What can happen? I create the additional script, hunt hint, and this script goes through the imported entry point. They find files for hinting. Also, they find how many hints used. Also, this script says me how many lines of code will be changed. And also interesting, in this script, I have collected information about the whole project. And we can see it's only around 2,000 class definitions with different functions. And it's around 7,000 function definitions in this project. And it's only a question for my developers. Boys, are you working in function-based paradigm or in object-oriented paradigm? And statistically, I see they work still with functions. Okay. But they say, of course, we work with OOP. Okay. Some hints, statistic. We can see some classes really important, some classes from our project really important to use in type hints, and probably we can avoid it. In this script, I change all classes on types any, because for data classes we cannot remove type hints simply. And what happens? After the script's finished, I have typing any everywhere. The project still works, but what we have many unused imports. After that, I use simply autoflake to remove all unused imports. And what I have, ta-da! Before it was 560 dependencies, and without type hints, we have only 505 dependencies. And also, we need not too much libraries to install, and summary files for files was changed. It was after the working with type hints, after removing the type hints, I have low lines of code. And it's around 25%. It was 40,000. Here I have the 30,000 lines of code. In this case, you can see the complexity statistically was reduced. And this is a truth which you cannot avoid. The type hints statistically increase the complexity of your project. I'm not against type hints, but try to think about it. Final check. How I can check if all works? Simply pack in container and run it. Of course, all should be covered with tests. But if you don't have any tests, like in this example, we can only try to run it. And also, we can also check if all works or not if we try to import any file. If import happens, it means statistically we did the good work, good job. Okay, summary. Small summary about my talk and how I spread complexity in different projects it was e-commerce platform, it was medical data lake observations project, it was the voice assistant project with more than 800,000 lines. At first, refactoring of huge database or codebase is not a solution. I'm completely sure about it. The second, we can easily isolate a selected part of code into a separate package. And after that, team can work only with this package. And of course, files which reuse code from other packages, these files should be transformed in additional model external dependency. If we import some objects frequently, probably it should be also removed in some external package. And the last suggestion, type hints statistically increase complexity of your code. And simply, you can think about it. Thank you for your attention. Slides you can find from all my talks, you can find in repository. And if you want, we can easily check any your project with my script, how we can transform it with my script, and you can use it. I'm here on conference, simply ask me about it. Thank you.
Thank you, Maxim, for your talk. Now, once again, any questions for the speaker?
Great talk, thank you. How to handle engineers that are attached to dry and solid, and if they don't want to embrace this approach and repeating code, and how do you approach them? I mean, it's also about people, right? So how to convince them or explain to them that this is a good way to solve the problem?
The best way to solve the problem, to create a code style guide for every project which you start. And after that, accordingly, style guides should work every developer. If in style guide we write directly, dry can be wet, probably don't repeat yourself paradigm. It's not too important for this project. Or other case, it should be dry as much as possible. And after that, every developer should follow this code style guide, because it gives the one form for whole project. And after that, I can do anything what I want, because I don't do any refactoring. I simply follow the style guides, and I pack the small parts of messy monolith in containers. And I do it exactly before production. It means if somebody wants to work with whole code repository, please. I don't want to break this decision. But of course, if you feel dry is broken, for example, or solid is broken, or something is broken, at first, what is written in your style guide? If it allowed, don't matter. If it not allowed, probably solution should be refactored. And only in the small situations, small cases, style guide can be overridden. But this is the last decision which should not be done. But my solution is simply splitting the messy monolith with the same rules on the small monoliths or small modules.
Gotcha. Thank you.
Welcome.
So my question is about, is this what you propose, is this a one-time solution where you do this split of the monolithic repository into different modules, or and then they continue the work independently, or is this just so they keep working as it is and is just for
Presentation.
or for splitting in the containers for the production environment?
At first it was invented for medical database, medical data lake. This data lake stored medical observation. It was really messy, and it was the first time there I implemented. In this project, it was split. The project was split on around 12 different blocks, and after that we have split teams on 13 teams, because every team works with this block, and one team work with core model. In this model, we have remove all repeated code. But after that, I like this idea. Also, it works together with micro Django paradigm. And after that, I started implemented, everywhere. And right now, I write all my projects or ideas in micro Django style. That's all. But right now, it was implemented in 4 huge project with 800,000 lines, 300,000 lines, 200,000 lines, and 32,000 lines. 4 projects. Once more time, we can implement the script on every project, and we can see what happens. Right now, I try to reduce image from PyTorch. It means I want to reduce 8 gigabyte image in small image, which use only functions and models which I need in my project. Once more.
Any more questions?
And what do you think about when we refactor code, we can find and optimize it while refactoring? And also, I understand that type hints, we can remove it if it's maybe a small project, but if it's in your case when you want to divide it, with removing type hints, and other programmers will just not understand your code, and they will try to understand it for weeks without type hints. Is it a solution for a big project?
At first, I can show you many professional code with type hints, which completely not readable, because it's wrong written. Also, some of these models implemented in raw Python. But I already wait this question about refactoring. About refactoring, it's so. Martin Fowler, many years ago, defined the idea about touch depth zero tolerance zone. We have in our project only the 5% of files which should be refactoring. Other files should be left as is. And in this case, refactoring can be applied on these 5% files in your repository, but all other files, please leave alone. Please don't touch it. And it's you can have a simple answer for that. For example, I write one file, and I got $100 for this work. After that, I start to refactor, but nobody pays for this refactor. And it means I worked with the files already 2 times, and it means for me I get for this work instead of $100 only $50. And if I start to work with this file the 3rd time, again I reduce the price of my work. After the 10 times, I start to work like a charity. But I'm not a charity, I'm a programmer which want to get the money. And in this case, refactoring is not a solution. And accordingly, statistically, idea from Fowler, we can define which files can be refactored and other files, please don't touch. The idea for clear described from Michael Feeders, and you can read about it. How to define which files you can touch, and after other part of your project, please don't touch. Only if you have a business goal and somebody want to pay for that, why not? You can refactor it.
If you're working at hourly rate and you can do refactoring as many as you want.
Yeah, probably.
Thank you.
Welcome. About type hints we can discuss later. But I await the example from this. I don't like type hints exactly because this. I describe what is it, but after that I should transform again. Don't repeat yourself broken into lines of code.
But it's not relevant for it is int and it will be pasted in.
Yeah.
Another it will be an error.
This example simply try to search in internet how many milliard lines of code breaks the don't repeat yourself rule with type hints. Right now, type hints wrong implemented in Python, and many people still work with that. Okay, why not? Sorry if I a little bit hard about it.
Pydantic tried to solve this.
Yep. About Pydantic, it was perfect talk on PyCon Lithuania. And on PyCon Lithuania, Pydantic developer of Pydantic declares which problem they have. And after this talk, I also discuss about problems with Pydantic. Pydantic used this wrong solution to create a good idea. Accepted. For that, Pydantic, it's perfect. But but the idea about type hinting in Python right now, it's wrong. Sorry. Yeah. My opinion. I'm finished. We can discuss it later. And welcome. Thank you.